Welcome to another math special video, and this time we again have a geometry problem. And this is a problem I solved some 5 or 6 years ago, and I did not have a habit of listing down the sources of the problem back then. So unfortunately I don't have the source of this problem. Okay, let's start. What we are given is a quadrilateral ABCD with two diagonals AC and BD, and they intersect at the point X. And what we are also given is the measures of these angles, as you can see in the figure. Okay, we need to find all the angles: angle A, angle B, angle C, angle D. Angle A, this angle, angle B, angle A, angle B, angle C, and angle D. That's what we need to find. Okay, for angle B and angle C, it's quite easy. You can use middle school geometry. Okay, even middle school students can find the values of angle B and angle C. Let's see, in triangle ABC, angle B plus 30 plus 70 means 180 degrees. So angle B is equal to 180 minus 30 degrees plus 70 degrees, which is equal to 180 degrees minus 100 degrees is equal to 80 degrees, like this. And for angle C, we look at triangle BCD, and this is what we need. Okay, this entire angle C. So angle C is equal to angle C plus 50 plus 20 is equal to 180. So angle C is equal to 180 degrees minus the sum of these two angles, 50 plus 20, which is equal to 180 degrees, minus 70 degrees equals to 110 degrees. Okay, there's no problem in finding these two angles. The main problem is to find angle A and angle D. Okay, angle A and angle D. Now, for further calculations, let's calculate these angles. Okay, now angle B, the entire angle B, is 80 degrees. This whole angle is 80 degrees, and this is 50 degrees, means this must be 30 degrees. And since this is 30 and this is 30, this triangle AXB is isosceles with AX equal to BX. Alright? Okay. Next, angle C is equal to 110 degrees. 110 degrees. So, since this is 70 degrees and this entire angle is 110 degrees, this angle should be 40 degrees. Okay? Okay. Now let's calculate this angle. This angle plus 30 plus 30 means 180. So this angle is equal to 180 minus the sum of 30 and 30, which means 180 minus 60. So this angle is 120 degrees. Alright, this angle is 120 degrees. So this angle should be 60 degrees. This angle should be 60 degrees. And this angle should be 120 degrees. Okay, vertically opposite angles and linear pair. Alright, you can assume either this angle or this angle to be alpha, or any other notation of your choice. I'm going to choose this one to be alpha. Okay, this one to be alpha. Now let's see, in triangle ADX, this is alpha, this is 120 degrees. Since this angle plus alpha is equal to 180, this angle is equal to 120 degrees minus alpha. So this angle is 120 degrees minus alpha. Now, one thing we need to note is that since alpha is an angle of a triangle, alpha needs to be between this, okay, must be greater than 0 degrees and less than 180 degrees, and since this angle is 120 degree minus alpha, 120 degree minus alpha must be greater than 0 degrees. Okay, this is an angle of a triangle. So alpha must be less than, if you send alpha here, alpha must be less than 120 degrees. Okay, 120 degrees. This is how it works. Alright, so alpha must be less than 120 degrees. Alpha must be less than 120 degrees. We note that. We'll need it later on in our calculations. Okay. It's less than 120 degrees. Okay. Now what we are going to do is we are going to use sine law in the 4 non-intersecting triangles. You can use intersecting triangles as well, but you might miscalculate something if you use intersecting or overlapping triangles, but you can do it. Okay, I'm not going to do it, but you can do it. If you want, you can try taking intersecting triangles for the calculation I'm going to proceed with, and you'll get the same result. You'll get the same result, but it'll be a bit lengthier and it'll be kind of gibberish because the figure is not so tidy. Okay, I'm going to use I'm going to use a non-intersecting and non-overlapping triangles to solve this problem. Okay, now let's see triangle AXD, this triangle ADX. Okay, this triangle ADX. Let's use sine law. What do we get using sine law? Okay, what we need to use is sine law. Now if we choose triangle ADX, and if we apply the sine law, what do we get? Let's see, we need the value of alpha. So if we say sine alpha, then sine alpha means the angle opposite to this angle alpha is dx. So let's put dx down here, and let's say sine 180 degree minus 120 degrees minus alpha. 120 degrees minus alpha over, now this side is ax, so let's put ax here. Now one thing what you can do is sine 120 degrees minus alpha is equal to sine 180 degrees minus 60 plus alpha. Okay, and then what you can do is you can use sine 180 minus something means sine something. So this is sine 60 degrees plus alpha. Okay, so we can write this as sine 60 degrees plus alpha over, we already have ax is equal to bx, so let's use bx. Okay, let's use bx. So what do we have? Sine alpha over sine 60 degrees plus alpha is equal to dx over bx. Let's call this equation 1. Now what we do is we already have alpha over here. Now if we can express this fraction or this ratio in terms of the ratios of sines of known angles, then we get a trigonometric equation, and solving that trigonometric equation we can find the value of alpha. Okay, all right. Now how are we going to proceed with this? We start with dx. over something times this something over some other something times we do it like this. Okay, we do it like this. So, and if this is a ratio of sines of known angles, and similarly and so are these, then we get a trigonometric equation, and we can solve that trigonometric equation in order to find the value of alpha. Okay, now let's start. We need dx over something. Okay, we need dx over something. So we start with dx. Dx is a side. We are going to look at these four triangles. Okay, we're just going to look at, you can, as I already said, you can choose, it's up to you, you can choose the overlapping triangles to proceed with your calculations. It doesn't matter, but I'm not going to do that. Now dx is a side of this triangle CDX. Okay, so triangle CDX, using sine law in triangle CDX, what do we get? We need dx, so we put dx here, and dx is opposite to this angle of 40 degrees, so we put sine 40 degrees over here. Now what we have is, okay, we can choose either CX or CD, but if we choose CD, it will be a side of only one triangle. It won't be a common side to any of the triangles. So let's choose CX. CX. Then CX will be a common side of this triangle and this triangle. Okay? Okay. CX, if we choose CX, then it is opposite to this angle. This angle measures 20 degrees. So sine 20 degrees. If we simplify this a little bit, what we get is sine 40 over sine 20 is equal to dx over cx. Let's call this equation 2. Next, cx is a side of this triangle as well, of triangle BCX. Okay, of triangle BCX. Now the triangle BCX, what do we have? If we use sine law, now we need to use CX. Okay, we need to use CX. So if we choose CX, then it is opposite to this angle. So this is sine 50 degrees. Now we can choose either BC or BX. Now if we choose BC, first of all, it's not a common side to any of the triangles, and next we need BX in the denominator. Okay, we need BX in the denominator, and if we choose BX, we definitely get BX in the denominator. So there's no point of choosing BC. So let's choose BX, and BX is opposite to this angle of 70 degrees. So sine 70 degrees. Now this simplifies to sine 50 over sine 70 equals to cx by bx. Now let's multiply 2 and 3, left hand side by left hand side, right hand side by right hand side. Then from 2 and 3, what we get? Dx by cx times cx by bx is equal to this times this. Okay? Sine 40 by sine 20 times sine 50 by sine 70. This cx cancels this cx, so what we get is dx by bx, and the dx by bx is equal to sine alpha by sine 60 plus alpha from equation 1. So from equation 1, what we can write is sine 60 degrees plus alpha by sine alpha. Oh, sorry, that's the other way around. Sine alpha by sine 60 degrees plus alpha sine alpha by sine 60 degrees plus alpha equals to this. Now if we carefully see, sine 40 means 2 sine 20 degrees cos 20 degrees, okay, over sine 20 sine 70, sine 20 sine 70 times what we have is sine 50. Now let's see, sine 70 means sine 90 degrees minus 20 degrees, which is equal to cos 20 degrees, okay, cos 20 degrees. So we can cancel out this with this, and since these two are equal, we can cancel out these two as well. Now what we are left with is 2 sine 50 degrees, 2 sine 50 degrees. So this is equal to 2 sine 50 degrees. We're quite close. Now what we do is, for the sake of simplicity, let's change this into cos as well. This is sine 90 degrees minus 40 degrees. So this is twice cos 40 degrees. Now, since we have sine here and sine times cos, we get a transformation formula for sines. And that will be easier for us to use because we have sine alpha over here. Okay, that's why I'm trying to use cos here. If we use sine, then we multiply this with sine 50, then we get something with cos, and we need to convert it into sine again. That will be a little bit tedious, so I converted this into cos right here. So what we get is sine alpha as it is, and this sine 60 plus alpha is equal to 2 cos 40 degrees. So 2 sine 60 degrees plus alpha times cos 40 degrees. Now let's simplify the right hand side. We know that 2 sine A cos B is equal to, sine A plus B plus sine A minus B, sine A plus B plus sine A minus B. Okay, we know that. So let's see, this is equal to 2, not 2, this is equal to sine A plus B means 100 degrees plus alpha, and A minus B, sine A minus B means, what do we have? A minus B means 60 minus 40 means 20 degrees plus alpha. Okay, so this is what we have. Next, 100 degrees plus alpha can be written as 180 degrees minus 80 degrees minus alpha. So sine 100 plus alpha is equal to sine 180 minus 80 degrees minus alpha. So it is equal to sine 80 degrees minus alpha. We write it as sine 80 degrees minus alpha plus sine 20 degrees plus alpha. Next, we send this sine 20 degrees plus alpha to this side. So what we get is sine alpha minus sine 20 degrees plus alpha. 20 degrees plus alpha, which is equal to sine 80 degrees minus alpha. Okay, sine 80 degrees minus alpha. Now we know that sine A minus sine B, sine B is equal to what do you call 2 cos A plus B by 2 sine A minus B by 2. So what we have is here sine 2 sine A minus B means minus 20 times cos A plus B by 2. 20 degrees plus 2 alpha by 2 means 10 degrees plus alpha. Okay, wait. A minus B by 2 means A minus B means alpha alpha. Alpha cancels alpha. Minus 20 by 2 means this is minus 10. It's minus 10. Sine 80 degrees minus alpha. Next, this is minus 2 sine 10 degrees because sine minus theta means minus sine theta. So, okay, cos 10 degrees plus alpha can be also written as cos 90 minus 80 degrees minus alpha. So this is sine 80 degrees minus alpha. So this is sine 80 degrees minus alpha is equal to sine 80 degrees minus alpha. Okay? All right. Okay, sine 80 degrees minus alpha. Now, okay. Now let's see. There can be two cases now. There can be two cases. One case would be that sine 80 degrees minus alpha is equal to 0. The other case will be that sine 80 degrees minus alpha is not equal to 0. If this is not equal to 0, then these two quantities cancel each other, and what we get is, if this is the case, this gives minus 2 sine 10 degrees, and since these two cancel out each other, what we get is this is 1, so sine 10 degrees is equal to minus 1 by 2. But sine 10 degrees must be positive, so, and we get a wrong result here, assuming that this is true, so this is not true. Hence, what we need to understand is that sine 80 degrees minus alpha is equal to 0. So, sine 80 degrees minus alpha is equal to 0. Now, solving this trigonometric equation, this is quite easy. Solving the trigonometric equation, we know that the solutions of sine x is equal to 0 is equal to n pi, where n is, we know that sine x equal to 0 implies x is equal to n pi. This is the solution of this equation, and n is an integer. Now, the general solution to this equation is sine 80 degrees minus alpha equals to, means using that logic, I don't need to write sine 80 degree, we have 80 degrees minus alpha instead of x, and the solution should be n pi, where n is an integer. Okay, n is an integer. But if we take negative integer, n pi means 180 degrees. If we take negative integers, then what will happen is you'll get, let's say, 180 degrees plus something, plus 80 plus some multiple of 180, means that will be greater than 120 degrees. So we cannot take negative values. So just for example, if we take n is equal to minus 1, then 80 degrees minus alpha is equal to minus 180 degrees. This will give alpha is equal to 180 plus 80, which is greater than 120 degrees. But this cannot be. As per this deduction, this cannot be. And if we take some lesser, negative by lesser means numbers less than minus 1, integers less than minus 1, then this will be much bigger, like this. So every time we take negative integer, we get the value of alpha to be greater than 120 degrees. This is not what we have. This cannot be as per this deduction. Okay, now let's see. So far it cannot be negative integers, so it needs to be either positive integers or 0. Okay, or 0. So let's say let's take a positive integer. Okay, say for example 80 degrees minus alpha is equal to, if we take 1, this is 180 degrees, and if we take alpha to this side, then 80 degrees minus 180 degrees is equal to alpha. So alpha is less than 0. You cannot have that, since alpha is an angle of a triangle. This cannot be less than 0 degrees. And if we take greater values of n, then you will get much more negative values. Okay, 360, 540, much more negative values. So we cannot take plus either. We cannot take negative integers or positive integers. We cannot take either of them. So the only possibility is to take n is equal to 0. Okay, n is equal to 0. So we must take n is equal to 0. So this gives 80 degrees minus alpha is equal to 0 degrees, which is alpha is equal to 80 degrees. This is the only possible solution for this trigonometric equation under this restriction. Okay, now we're almost done. The value of alpha is 80 degrees, so this is 80 degrees. Next, 120 minus alpha means 120 minus 80, so this angle is 40 degrees. This angle is 40 degrees. So angle A is equal to 30 plus 80, which is equal to 110 degrees, and angle D is equal to 20 plus 40 degrees, which is equal to 60 degrees. Okay, in this way we can find all the angles of the given quadrilateral using the given information. Okay, this is how we do it. All right, thanks for watching. This much for today. In the math special video, I'll be back with some more tutorials and some more math special videos very soon. All right, bye bye.